as a multi-node setup. So this was part of my requirement for testing OpenStack with Terraform, and that brings me here to do a latest setup for OpenStack. Now I tested already this with Antelope version, and I decided to just make a quick video. So uh, like a kind of a walkthrough of how the setup goes through with Antelope. Yes, there were a lot of challenges I faced during my first setup, second time also, but then that's why I just want to document it with a video. So it will be a series where I'm going to divide it in different stages, like the setup stage for the operating system, and then the configuration of the operating system, installation of the repos, and then finally running the pack stack. So yes, we are going to use the pack stack, which uses Puppet for the setup, and the whole motive of this video will be at the end we should be able to browse and access OpenStack Horizon, which is the UI. So this is the setup that we will follow, which is there currently on my screen, and we will be using CentOS Stream 9 operating system. So Stream is basically a version which falls in between Fedora and Red Hat. So before the main release of Red Hat, it is the CentOS Stream 9 operating system where the developers or the open source coders test in the Stream 9 operating system. And then the release of minor version for or the patch version for Red Hat happens. We will kindly excuse this sheet because it is not updated. We will be having a one compute node, so and one network node. I think this is not updated sheet. So we can just I can just delete this line, and we will be having one network node. Yeah. So we will have one controller, compute and network. Our controller node will be hosting the storage also, and other important services for OpenStack, which we all know it has a lot of services. We can call the management services for OpenStack to talk to each other and uh, perform the rest of the operations. We have the heat. We will be installing the heat, of course, the Cinder, of course, the Nova, Neutron. These are the recommended or mandatory services for OpenStack to work. We will be using Swift also for Glance. Glance is the image registry for OpenStack, and image registry in the sense like whatever images we upload gets stored in the Glance, and it can be browsed by the Nova or the Horizon in the UI, and we can upload it. So controller will be the main node, of course. I tried this to do on OKD cluster, which is the open source Kubernetes cluster, but it is failing. But I will still try. But since I wanted to test this using Terraform, my main motive was not to deploy this as a container solution, but to do it and test it with Terraform. So then I came up with to do a type 2 hypervisor. So I'm going to use VMware Workstation uh, for this setup, and the IPs might change. This is from my previous installation. So without wasting any time, let's start with the setup. So we are going to start with the installation of the servers first. So I'm using VMware Workstation for my type 2 setup, and I'm going to start with creation of new virtual machine. So we will deploy one VM, do the modifications, and then clone the rest of the two VMs. We are going to deploy controller first for sure. And I'm just giving Red Hat Enterprise Linux 9 to make things easy. I will give the name as controller. and I will create the OpenStack folders here so we can isolate with the rest of the files. So I will create three: controller, compute, and one more is the network or neutron, whatever is visible for you, you can put it. What makes you easy to understand. I'm going to browse. So this is basically I'm browsing where I'm going to store my virtual machines file. Uh, so it will have multiple files, VMX, most importantly the VMDKs, the state file. So I'm going to use two processors. By the way, my type 2, this is a type 2 setup I'm doing. So my base operating system is Windows, and I have an Intel NUC, next unit of computing. I have hard disk which is limited to 500 GB. It's an i7 and I think i5. I'm sorry, it's an i5, but I have 64 GB RAM. I will be allocating 16 GB for this nodes, all the three. I have tested with 8 GB and it will work fine with 8 GB also, but provided it will, um, you might face some slowness problems. I haven't tested that. 16384. Okay. So now, okay, networking part. Uh, Let me just add a NAT network in this case. Now for this is what I'm going to deploy controller. Controller is going to also host the Horizon dashboard. Uh, to be honest, for controller node, we just need one interface, but we will also have one bridge interface, which we will use to access the SSH, and we can also access SSH using the NAT. But then we will change the Apache configuration. Like Horizon is going to use Apache um, to access the dashboard. So as of now, I will add a NAT network. This is the disk configuration. I have an NVMe hard drive. I will create a new drive. This I will just use a single file and 20 GB. This will be a thin provision disk. And okay, I'm going to run finish. Okay, I have the controller node I can see here, and let me quickly just see the settings here. So I have an adapter here. Okay, and here I'm going to attach the ISO for CentOS Stream 9, which I have downloaded. And let me just power on this virtual machine. Okay, we are going to do the setup now. So we are just going to install the CentOS 9. We will do the minimum install, and let's see. Okay, I'm going to change the language to English. Yes, we will do with the UI, and the timestamp is correct. We will select automatic partitioning because I don't mind, because we are going to add a new disk for Cinder, and that same disk we will partition even for the Swift. Set the root password. We will allow the SSH. It's okay. I mean, this is just a home lab, and we will create a user OpenStack user just in case. We don't need it, but I will still give a sudo access. And okay, let's go to the network settings. I have one interface. It has taken the IP address. I will give the host name. I don't have an FQDN right now, but I will configure this for a static IP. So I don't want a DHCP 192.168.109.136. My NAC network is using this subnet which I have attached to the virtual machine, and that's why the subnet is 192.168.109.0/24. That makes my net mask as 255.255.255.0, and 2 is my gateway. DNS is same, 192.168.109.2. IPv6, I'm going to disable this. I don't need any security profile as of now. My installation source is this. Okay. So I will pause the video and then we will continue with the rest of the process where we have to create two more VMs, compute and network. Okay, we will just do a reboot, and we already assigned a static IP, so we will take a putty session to do rest of the config. But before that, okay, the ISO is already unmounted. So this was the user we created, OS user. It doesn't matter now because we also made the. I'm going to use putty now. I'm going to take a new session. So 192.168.109.136 is my management IP. So there are few steps that is mentioned for the. Now, yes, it is advice. I mean, my advice here would be that we should not use root as direct login, but since this is lab, I just using root. I have a sudo user also, and then I can log in with sudo user and then do sudo su hyphen with that user to log in as root user. So I'm just following this RDO project uh, for installation of OpenStack using Packstack. So I hope we are aware of what is RDO, and so it's a community which contributes for using and deployment of OpenStack. So here I just followed the setup which was provided here. So it's basically this step provides the installation of installation of OpenStack using Packstack as a proof of concept cloud. Well, they give the setup for all-in-one. All-in-one is where you have one node and we deploy everything on one node. When I say deploy everything means we deploy Neutron as well as Nova also on the controller. So there is only one node and everything is running on that specific node. I just wanted to segregate the services to make more sense of how things work because more fun is neutron networking, to be honest. Also, when we do migration, we want to see how traffic flows from one node to another node. So, yeah, so that's the reason I wanted to use multiple nodes. And so the initial step here, this is the basic that we will do for all the nodes. And that's why then we will clone the rest of the two nodes. So I'm going to perform this. We have already set the host name. So this is controller. I have one interface on that. We will disable the firewall. And we will also, okay, and better we put we disable the SA Linux. And I think we also need to disable the network manager. Okay, just check that step. Yes, we can stop the network manager. Okay, and okay, now so this is CentOS Stream 9 and it does not have the network scripts installed by default. So this is changed from, I'm not sure if it is changed from the version 8 itself, but this version for sure doesn't have that, which is the Red Hat 9 or CentOS Stream 9. So if we disable the network manager during the system boot, definitely the IP address will not be assigned. This IP address will not be assigned anymore to the node. I think we also want to just okay, IPv6 seems to be disabled, which is good. And rest is if we can assign one more network interface here, as I said before, which will be a bridge interface. Okay. Let us check what repos we have currently. So DNF list, and we need to have the I think CRB repos, which is the repo for OpenStack, and this enables the OpenStack repository actually. So yes, this setup shows for Caracal version, but I have tried for Antelope. I haven't tried the Caracal. So how it goes is it's Antelope, then it's Bobcat, and then it's Caracal. So we will definitely enable this one first. Okay. And we will go ahead and do the installation of not Caracal, as I said, and we will use Antelope. Now, since I am NAT, but still my internet is working and reachable, okay. It's just that I'm using an NAT network. So I will just install this. Let us wait. It is just doing a make cache right now because I'm running the DNF for the first time. So whatever repo is enabled, it will try to make a cache. Okay, and we can also do one more thing. Let us also install uh, the init script so we can disable the network manager, because it's recommended by the documentation, if we follow in the RDO website, which I was just sharing here, that it has to be stopped and disabled. So we need the NMCLI will not work. In that case, we would have to use the IP commands, but we need the network configuration persistent across reboot, and that's why we need the init scripts, network scripts, I'm sorry. Okay, we are going to install this. And once this is installed, we will be installing the network scripts. So these are the prerequisites. Init scripts is a prerequisite for network scripts, and that's the reason we accept the key. Okay. Now for this to work, we just go and create a we check the interface and we create ENS160 if config file. We give the basic options like name, and one is device. IP ADDR will be 192.168.109.136. We will have a prefix of 24. We will have gateway of 168.109.2. We will have on boot as yes, and default route it will take automatically. We just make sure we're not missing the important things, otherwise the interface will not come up. As far as I can recollect, this will be enough once we reboot it. Onboard gateway prefix, IP ADDR, device name. There can be UUID, but it's not required. IPv6, we have already disabled it. And okay, we can try to reboot. So first, we will do a systemctl stop network manager, and then we disable it so it doesn't come up once we reboot the system. Yes, one more thing, we have to enable the network service. So we got the network service when we install the network-scripts. So because if we don't enable that, it will not come up during the runtime. And we also start that. It doesn't make sense right now, but still, because we don't have network manager right now. What we will do now is we will just go and perform a graceful shutdown or a restart guest, it's fine. We wait for the server to just reboot it. Okay, let's see during the restart if any IP configuration. It's pretty fast actually. Yeah, it's up now. Let me just restart my party session, and if it restarts successfully, that means the network configuration was correct. Yes, it is. So we have NM's network manager stopped. Okay, we can see that using, it will say network manager is not running. That means we still got the IP addresses using the networking service, which we install outside of the repos from CentOS 9 stream. Okay, this is the requirement, one of the requirements for OpenStack to disable the network manager. Following the documentation that we have finished the installation of Antelope, and now we have to perform an update. Okay, so we will do an update for the operating system. Okay, and it says cannot install both init scripts from the base OS and init scripts from add system. Okay, what we will do is we will remove the network scripts which we installed earlier. Okay, that was 11.4. Okay, and we will then perform an update. Okay, okay, let us try this way. It will also remove the network scripts. Oh, we can do one thing. We can, okay, we remove that. Okay, we will perform a DNF update now. Okay, this will work. And then what will make sense is we will again perform the installation of these packages which we installed. So what would have made sense in the steps is first we would have approached the update of the operating system, and then we can install this packages. Yeah, that will make more sense. So still we have now, but the problem is since we had removed it, we have to do check config or a systemctl enable network and start the service, which is already started since we enabled it. It's not native, it says that. Okay, fine. Now, the next step here is to install the Packstack. Now, Packstack we just need to install on the controller node and not on all the other nodes. We don't want Packstack in compute or network node. So, but before that, we want to take a snapshot of this VM, and even before that, better we clone this VM to for so it's like a template for us right now. If we clone this, we just have to change the host name and the IP address, and rest are the default system settings that we need. So what I mean to say is we need this OpenStack RPM or setup of Antelope to be present across all the nodes. It has to be present in compute. It has to be present in networking node. But Backstack we just need here because it's just an installer which will orchestrate the installation. It will also run the required binaries in the respective nodes like networking and compute nodes. Okay. So what we will do now here is even before we need to clone this and create two more servers. Then we come back here, create the sender volume and a Swift volume, which we will be using for glance. And then we take snapshots of all the three nodes. Okay. So we are going to shut this down again. Okay. We are going to take a clone. So I don't want a linked clone. I'm going to take a full clone. Let us do compute first. So here I'm just storing my virtual machines file, which we created earlier. So if I just follow my inventory, we are done with this one. IP is correct. I still don't have the bridge interface. Okay, I haven't added that. In fact, I should have added that. Mhm. So it's okay. We can still add now. Now this is my compute node, and I will just power on this node. We will keep the settings as it is, like 16 GB, 2 cores, and 20 GB. Yes, the adapter here will also be NAT. So here we are going to have now three interfaces in compute node and three interfaces in network node also. So right now we can see already we have one NAT adapter. We will add one more adapter here. Okay. So now in this configuration, I just want to show what is my current networking setup here. So this is the network which VMware Workstation is providing. Currently, what I'm using in the servers is VMnet 8, which is NAT. Okay, this is the subnet it is using to assign the IP addresses because I have the local DHCP on here, and VMware Workstation networking setup. Okay, and I have created this VMnet 10, which is the custom NIC. Okay, it has this IP settings 172.16.24.0. Now this we will use as a third interface in our compute and network node. So basically this will be our we can say a tunnel interface for VXLAN. We will be using for tunneling VXLAN. There are other protocols which we can use. Geneve, GRE. I have tested this with VXLAN, so I want to use this VXLAN. And so basically it will perform a layer 3 over layer 2 where the packets will be encapsulated when two different hosts, the two different VMs wants to communicate with each other sitting on two different nodes. So yeah, so that's how when VM residing on one host and VM residing on another host, they wants to talk. So at that time, this will make more sense. So this is where I'm going to assign this VMnet 10, and this is a bridge network, which we will be using, yes, for external networks. So that means this bridge network will have an uplink from the operating system. So So a physical interface, okay, which we will add in the compute node. Compute node will have a NAT interface and a bridge interface and the custom interface. Same goes with the network node also. Now my API services, all the API services, the traffic is not segregated, and we will still be using the NAT, which is the management interface, the management subnet, which is 109, okay, and that same will be used. Okay, so this is just, I wanted to show that this is the setup, because now in the compute node we already have an NAT adapter, and we will be adding one more adapter. We will change this to, we need an external, yes, we will change this to, first let us add a bridge adapter, uh, okay, and we will just commit, we can still add together one more adapter we need, and we will add one more, which is going to be our custom, which is VMware 10. So this is for the VXLAN. Okay. Now we can power on this node. It will take the management IP, and I don't want any arc to change, so better I will just not connect this at power on. We will change its IP address and then we will connect the interface. So we have to access the VM right now using the console because it won't be available over the network. It's taking some time. Okay. And we can do a sudo. Let's log in with this user here. So this is the CentOS 9 screen in front of us. We'll do a sudo and just log in. Okay. We can see we have three interfaces now, and 224 is the bridge one, 256 is the tunnel one. Basically, actually what happens is we don't have to assign IP address to ANS224 because this will be part of the bridge actually. So we don't have to assign IP addresses to this network. And we can assign IP address to ANS256, which is not required at this point of time, but still we can do that. But what is important right now is just to change the uh, IP address for ENS160, and we will put this the next IP address because I know it's free, so I'll just put 137. Let me also copy 160 to IFCFG ENS224, and I will copy this to 256. We need to change few things like ENS224. will not be having any IP address details. We need to change the device details, and of course we cannot have the gateway. Similarly, 256, we will change the name. So we will put this as 256. The name will be 256. The IP address which we have used from our network settings, which is this, I will start with 10. My prefix is correct. We don't need a gateway for this. And on boot is yes. We will now change the host name for this node, and we will put the host name as compute. We will now restart this node and see if the IP address assignment was correct, and we can access the server using PuTTY. The server is up. I'm going to take a new PuTTY session. 192.168.109.137. Okay, I need to check what was the IP address I assigned. We can directly check it here. 192.168.109, and what is the gateway? Are we able to reach the gateway? Okay, we are not able to reach the gateway. Of course, yeah, I forgot, sorry, because we have I forgot a step in between where we had not selected we had unchecked the network adapter, so how it will work, not work, makes sense. And I will just do OK. I should be able to get the ping response now, which is fine. So we have this compute node up and running. Okay. Now we have the setup, we have the update also. Let us also clone the compute node. So we have the required interfaces, because as I said, we need 3 interfaces again in the network node. So it's better if we clone from compute node rather than the controller node. And at the same time, we can now power on the controller node because we have already assigned a different IP address to compute node. Let us clone my compute node to, sorry, from clone. This will be my network node. I have a separate directory for storing the virtual machines, and I have Openstack here, network. We'll finish it off. So we have the network node. We can see here, this is the network node. We have the same config with the disk. We have 3 adapters, NAT, bridged, and this is the custom, which is for the VXLAN. Okay, we can power on this, but before that, again, let us just disconnect the interface, and now I can power on the compute. And I can also power on the network node. Of course, the network node will not be reachable. We have to access it using the console. Okay, we are going to access the network node, and first thing we will do is change the management IP, which is the first interface. So then we can access it using the PuTTY. IFCFG ENS 160. And I'll give the next IP address, which is 138. So we are aligned with my inventory, which I have here, if you see. So this is not the correct one, 192.168.109.137 and 192.168.109.138. And let me do an if down ENS 160, and now I can do if up, and we can connect the interface now. We should be able to take PuTTY session and do the rest of the IP address change for the third interface, 138. Okay, finally. And we also need to change the host name. So this will be host name PuTTY, set host name to network. So, and we will just go to etc sysconfig network scripts and ifcfg ens 224, oh sorry, 224. Anyways, we don't need to give the IP address. So what is the third interface? It will be 256. So ifcfg ens 256, and we will give this as 11. Okay, and we do an if down ens 256, and we do if up. We cross check the IPs are correct. We do a ping to .10. Excuse me. So it's reachable. We have this interface reachable. Of course, we will be having the rest of the interfaces reachable because they are part of switching and not routing. Same subnets. So let us take a PuTTY session for all the nodes. This is my controller. .137 will be my compute node. Okay, and then the third one we already have, which is this is my network node. Okay, 138. Most important thing, RabbitMQ needs, and also the other services, they communicate using the host names. Even in Packstack, we can provide the FQDNs of the nodes, or we can give the IP addresses. I have tested this using the IP addresses and not host names. I'm going to follow the same process. It doesn't fail anywhere in between. But yes, I had faced a challenge with RabbitMQ, which is a messaging queue for all the services that interact with each other, and that's why it's important to put the EDC host entries. IP address first, 192.168.109.136 is my controller. We'll copy paste, and this will be 37 and 38. So compute, and this will be my network node. We will copy this, and I'm not using DNS, I'm using the local etc host file for name resolution. And add in the rest of the nodes. Okay, and let us do a ping check from any of the nodes to compute, so it should be able to resolve it, which is what we want. Oh, I did from, this is a network node. Okay, this is a compute node. Okay, let us do to network node. Okay, it works on 138. It is able to resolve that. So now we have the three nodes ready, and we can proceed as a first step to save this as a, as a blueprint or a template. So if we fail from now, if we fail for rest of the steps, because OpenStack can fail and we might have to, repeat the steps. So better we take a snapshot. So this is a fresh setup or a prepared prerequisite setup for the Packstack installation to start. So we will shut down all of these nodes and we will take snapshots. So we can shut down either from here or we can shut down it from the operating system. So, okay, and let us take a snapshot now. This will be snapshot before Packstack installation. Better we put like that. Take the snapshot. Okay, so if we see, we should be having an option to revert, and the snapshot manager will show us that now we have moved one step ahead, and this is my snapshot. And you can also, when you do go to here, it will take us here and it will actually revert to this snapshot. And otherwise, we can just right click and perform. Sorry, from here we can do revert. Okay. So yes, so this is the first step for our OpenStack Antelope setup, multi-node setup, and I hope my video was clear uh, as far as the lab setup is considered. Now we will proceed further in the next videos where we will create the answer file for Packstack. So Packstack will read the answer file and perform the installation of OpenStack on the respective nodes, compute, network, and the controller. Thank you for watching and hope to see you in the next video.